Okay, 13.6, we have the normal curve. There's a lot of vocabulary, but problem set 1, we have the cholesterol levels for females are normally distributed in a random sample of 500 females. Determine the approximate number of females in the sample who are expected to have cholesterol levels A within 1 standard deviation of the mean and 2 within 2 standard deviations of the mean. So to do these calculations, what we want to do is say that 1 standard deviation of the mean refers to 68%, because if we refer back to the book, we know that 68% or 0.68 has most of the datas within 1 standard deviation of the mean. And all we have to do is take our decimal and multiply it by the amount of females that were in the sample. And to do that, the 0.68 times 500 yields 340 females. For the next part, within 2 standard deviations of the means refers to 95%, which written as a decimal is 0.95. And then you want to multiply it by the sample size, which was 500. So 0.95 times 500 was the 475 females. And that is all you have to do. This is the problem set for that part. Now if we look for z-scores, there's a simple formula right up here on the top of the screen to finding z-scores. So for these, we know that the mean is 90. They're giving us the z-score, and we know the standard deviation. So for part A right here, z of 90 equals value of the piece of data, which is 90, subtracting the mean, which is 80, and we have to divide by the standard deviation, which is 10. So 80 minus 90 minus 80 is 10. Keep your division of 10. 10 divided by 10 is just 1. To continue this pattern, let's use our formula for Z95. So Z95 is the formula 95 minus 80 divided by 10. So 95 subtracting 80 is 15. Divided by 10 yields the answer 1.5. Let's continue our same method of Z80 equals 80 subtract 80 divided by 10. So 80 subtract 80 is 0 on top with 10 on the denominator. 0 divided by 10 is 0. And finally, for Z of 64, we have 64 minus 80 divided by 10. When we work on the numerator, we get a negative 16, still with our 10 on the bottom, so we have a negative 1.6 as the z-score. Okay, so for this next part, determine the area under the normal curve. So with the normal curve, there's this shape, and we are looking for different parts of the z-scores and what the area is going to be. It's going to be shaded in, or what we're looking for. So if you need to refer to your book, you can use pages 822 through 823 in your textbook. It's going to give you the area under the curve chart. And if you're looking for the area to the left of z of being negative 1, you're going to find you have 0 decimal 1587. To the left of z being 1.19, you should get 0.8830. And to the right, not right, of z being 1.19, it looks a lot similar to C, except we're looking at the right instead of the left. So we found the left, and to find the right, all you do is have to take that, it being subtracted by 1. So 1 subtract 0.8830 gives you an area of 0.1170. Okay, and now we're looking between two places. So z being a negative 1.62, that's going to give you an area of 0.0526, while z being 2.57 is going to give you an area of 0.9947. And now what you want to do is take the largest positive one, so that's 0.9947, subtract it by the lesser, so 0.0526. And that's going to give you an area of 0.9423 as the area between those two z values.